Hello and welcome to this module on building sanitation systems. In this module, we're going to combine everything that was covered in the previous modules, the products, the functional groups, and the technologies into complete systems. The goals of this module are to first introduce what a sanitation template is, second, to understand how to work with the sanitation template by following the flow paths of each product and then selecting each technology for each functional group, and finally, to be able to build a complete logical sanitation system. This is an example of what we call a system template. We will discuss each of the parts in detail as we progress, but for now, let's focus on the products. The products, as you will remember, are the materials that flow through and are generated within the sanitation system. We read the system template from left to right. On the left, you can see a list of the products in the first column, input products. You can identify the products by the rounded side and the color, as well as the name, of course. You can see that there are lines connecting the products to the rest of the elements in the diagram. These lines indicate the flow path of the particular products, so it shows you what technology the product will pass through. You can see also that there are two thicknesses of lines. The thicker black lines are those which are most commonly followed and should be considered as the most important. The thinner lines are those that are somewhat less important or optional. For example, the main products are feces, urine, and flesh water. These are all connected together with a thick black line that flows into the first red box. We'll talk about these boxes later, but for the moment, look at the bottom of the products and look at the anal cleansing water and the dry cleansing material. These two products both have thin lines attached to them because realistically, they're not the most important thing to consider. Also, you'll notice that the thin line goes in two directions, up and across here. That means that the products can go either to this first technology box over here or be mixed in with the products above. The choice would basically depend on the local context and conditions. It's worth stressing here that although we use system templates to help us guide the decision-making process, they cannot solve all of your problems. There's still a fair amount of context-specific information and engineering that's needed to build a proper system. What we can also see are the products that are within the system. Black water, for example. Fecal sludge is another example of a product that did not go into the system. Notice it was nowhere here on the left. Fecal sludge, like all the other products that you can see within the system, emerged from different technologies. Some of the products will emerge in the same form as they entered, and some of them will be transformed, like how urine and feces and flesh water were transformed into fecal sludge and effluent. Now we're going to focus on the functional groups. The titles of each functional group are listed across the top and are color-coded the way they were before. Within each functional group column, there are technology boxes. Each technology box under each functional group heading lists the possible technology choices for that functional group for that product. In essence, it is like a matrix. The products are listed on the left and are flowing from left to right. The functional groups are the columns, and where the functional groups intersect with the product paths, for example, here, the technology options are listed in the technology boxes. You will notice that there is not a technology box for every functional group. Not every product requires a technology from every functional group. Gray water, for example, does not enter the system through the user interface. Remember, it comes in from another water source in the house, but not the toilet. Therefore, the gray water bypasses the user interface and enters the sanitation system directly at the point of collection and storage. In this case, it could be a septic tank, an ABR, or an anaerobic filter. Your job, therefore, as the engineer, is to follow each product along its flow path until it intersects with a relevant functional group and then choose the most appropriate technology from the options listed. The choice will depend entirely on the local context and conditions. Let's actually do that now and select the technologies that we will need to form a complete sanitation system using this template as an example. Normally, we would know much more about the population, but in this case, we're going to have to make some assumptions. Let's assume that the population is made up of wipers and that they throw paper in the toilet, so we don't need a separate technology for it. Our gray cleansing material will follow this light line and mix it in with our urine, feces, and flush water. The urine, feces, and flush water, along with the toilet paper, will all flow into the user interface. And here we have two options. We can either choose a pour flush toilet or a cistern flush toilet. Let's, for the case of this example, choose a pour flush toilet. Here it is. We've marked it down so that we can build our system and continue from here. Once all of the products go into our pour flush toilet, they are mixed together and referred to as black water. The black water needs to be collected and stored. So here, it flows into the collection and storage functional group, and again we see we have three choices: a septic tank, an ABR, or an anaerobic filter. Let's say that we're designing for a small group of houses and there's a little bit of space, so we want to install something that's a little bit robust that can handle the variation of the black water inflow, and we decide on an anaerobic baffled reactor. Here it is. We've selected it for this technology interface. The ABR creates two different products, the effluent and the sludge, which settles to the bottom. The effluent, which is created constantly, needs to continually leave the system. In our example, let's say we have a bit of space, so we can pipe our effluent into a soak pit, shown here. The effluent will infiltrate through, and because we have some space, will be absorbed by the soil without any real impact on the surrounding area. So we've taken care of the effluent, we've followed it through. Now we need to deal with the sludge. The sludge that accumulates into the ABR will need to be emptied periodically. So let's assume that we are working in an area that has emptying businesses that own and operate pump trucks to suck out and transport the accumulated sludge. Here's our truck. It's come along and it's emptying this layer of sludge from our ABR. The truck will now need to transport it. We're lucky in this case because there is a functioning treatment plant dedicated for the sludge. It happens to be based on a planted drying bed. Here we can see the planted drying bed with the truck emptying the sludge into the grit chamber. The sludge will be layered on top of the filter. The effluent will filter through the porous layers beneath and will come out on this side. The sludge, as it accumulates, will dry and be turned into a dry sludge product. This dry sludge that comes off will need to be taken care of in some way. So what we're actually going to do is just give it away to some of the local farmers so that they can use it as a soil amender and help to improve the porosity and water storing properties of the soil. Remember, however, the planted drying bed produces two products, that dried sludge, which we've given away, but also the effluent, which comes out here and which needs further treatment. What we're going to do is dump it into one of the small local waste stabilization ponds that happens to be nearby. Quite lucky for us, but also a very useful technology. So the effluent from the planted drying bed that we have here will flow into our waste stabilization pond. Now, as a final step, we need to get rid of all of this effluent somehow. So what we're going to do is we're going to actually put fish into a final finishing pond and dilute that effluent so that we can grow fish and hopefully generate some revenue in the process. Of course, we could have chosen different technologies at each step for every product, so this is just one of many possible combinations. But still, you can see how we linked all of the technologies for each of the products all the way through to the very end. Furthermore, this is just one template. The choices we had were limited because of the type of input products and the logical sequence of technologies that were specific to this template. In summary, the system template is like a matrix of products and functional groups. Technologies are selected by following flow paths that guide each product through the necessary functional groups. There are a variety of technologies that can be chosen, so the ultimate decision is based on the context, the designer, and the end-use objectives. In the next section, we will discuss the 9 different templates that include nearly every possible technology combination.